In earlier video, we discussed regarding inference rules and the closure of functional dependency and closure of the attributes. So for given functional dependencies, with the help of that one, we can derive the new functional dependencies using the inference rules. So those given functional dependencies and derived functional dependencies, if we are combined, that one we call as what? We call as a closure of that particular functional dependency. In the same way, what are the attributes comes in this functional dependency? So given functional set of attributes in the functional dependency, and after deriving from the inference rules, what are the new functional dependencies will get? No. So there also what are the attributes will get? So those things what we call as a set of closure of attributes. So in this video, let's discuss about regarding equivalence sets and the minimal cover. Once again, it is depends on your inference rules here. So let's see what actually equivalence of sets of functional dependency. For example, assume that here they given two functional dependencies f and g are equivalent. When we call these two functional dependency sets are equivalent, if every functional dependencies in f can be inferred from g. So in the G, what are the functional dependencies that you are having? No. So those functional dependencies we can infer from the F, or okay, this may be possible, and every FD in G can be inferred from F here. So these are the two given functional dependencies. So after applying the inference rules, what are the new inferent functional dependencies we'll get? That may be okay, may be available in G, or in the same way in the G given functional dependencies are there. After applying the inference rules, what are the inferred functional dependency will get? That may be there in this functional dependency F. So then we call that F and G are equivalent when if closure of F is equal to closure of G here. Okay. So let's see definition of this one. F covers G if every functional dependency in G can be inferred from F. That is, if G plus, okay, G plus means what it is? It is closure of G. It is subset of closure of F here. F and G are equivalent if F covers G and G covers F here. So let's see same this equivalent set with one example. Here given two functional dependency sets, that is F and G. F contains functional dependency sets, that is A determines C, AC determines D, E determines AD, E determines H. Okay, these are the set of functional dependencies available in F. In the same way, A determines CD and E determines AH are the functional dependency sets available in G. Now our aim is what? We need to check whether F and G are equivalent or not. So as I told, in the equivalent set, closure of F it is equal to closure of G, then we call that as F and G are equivalent. So now we need to find what? We need to find first closure of N and F and closure of G. After finding this two, we need to check whether both are equal or not. If it is equal, yes, F and G are equivalent. So let's see, first we find the closure of the F here. So that's one we denoted like this. F plus means what it is? It is closure of F. So given functional dependency sets are what here? A determines C, AC determines D, and E determines A, and E determines D, E determines H here. Actual given functional dependency here it is what? E determines AD. That one I decomposed like this. E determines A and E determines D. It doesn't make any difference to this functional dependency. Here I used which inference rules? As using inference rule 4, decomposition rule. Okay. So now here thing is what it is. These are the first closure. After applying the IR4 decomposition, I got these two as a new functional dependencies. Later I use that as what it is. A determines C here. For that, both for left hand side and right hand side, I added A here. So if I add the same attributes on both the side, it doesn't make any difference to your functional dependency. This one it is available in which rule? As rule 2, that is the okay argumentation rule. it tells that is what, if I add the same attribute on both the side, it doesn't make any difference to your functional dependency. That's why I added the A on both the side. Later, okay, so this is A determines AC, and here AC determines D is already given. So that one also I taken here, AC determines D and AA determines D here. How I got this one is, here you see AA determines AC and AC determines D here. So as we know that you are having one more inference rules, that is transitive rule. What it tells, if X determines Y and Y determines Z, then you can tell that is what, X determines Z here. So here X is what it is, AA, and Z is what here, D here is. That's why AA determines D here. So by using which rule we got this one? By using the inference rule 3, that is the transitive rule here. Yes, that one I can write like this, A determines D here. AA or simple A if I write, it doesn't make any difference to your inference rule here. Yes, this is the closure of F here. So these are the three inferent rules whatever we got from the F with the help of the inference rules 4, 3 and 2 here. So 1, 2 and 3. These are the three new rules are derived by the using what it is, by using inference rules 4, 2 and 3. So this is closure of F. In the same way, I need to find the closure of G here. So given functional dependency is here, I need to find the closure of G. So first I will make the thing A determines C and A determines D. Here given is A determines C and A determines CD. After applying the fourth rule, that is the decomposition rule, I got the new functional dependencies, that is A determines C and A determines D. Doesn't make any difference to your functional dependency according to decomposition rule. In the same way, E determines AH. After applying the decomposition rule, we got the new functional dependencies. E determines A and E determines H here. So now this is the first step. In the same way, for this A determines C, I used argumentation rule. AC determines, same attribute I added on both the side. AC determines CD. So now here AC determines C here and AC determines D using the inference rule 4 here. So here thing is what it is, AC determines CD. After applying here given functional dependencies, A determines D. After using the argumentation rule, I added C on both the side. Once again I use the decomposition rule, that is AC determines C and AC determines D. Okay. In the same way, here E determines H is given and E determines A is given. So here I use E determines E is there, here it is there, and in the same way A determines D is also there here, that one. Okay. So here it is given. A determines D is available here and here E determines A is available. After applying the third inference rule, transitive rule, I got E determines D here. So this is closure of G here. So you may have the question, why madam is doing all these things? Simple thing. If I see, F and G, is it equivalent now? All the functional dependencies what are available in F, same functional dependencies, or is it available in G? No. So if generally if I ask whether these two are equivalent or not, so you can tell that these two are not equivalent. But you can't tell like that. First you have to find the closure of F and closure of G, and later you check same functional dependencies whether it is available in F or not, whether it is available in G or not. If it is available, then we call these two are equivalent. That's why here we are finding what? Closure of F plus and the G plus. First functional dependency here given is what? A determines C. This is here, but that one it is not there here, because here it is having the A determines CD here. After using the decomposition rule, I proved that yes, this is also there. This A determines C and this A determines C, same functional dependencies are available in F and G now when after applying the decomposition rule. Next is here they given AC determines D here. That AC determines D is not available in G here. Then what is the thing here I need to check? So now I want to find that AC determines D in this also. So for that, what is the procedure we done here? So my aim is what now? AC determines D is available in this F. So after applying the inference rules, whether it is possible to get AC determines D in G or not, let's see. So for that only, what is the procedure we done here? We applied augmentation rule by adding C on both the side. We got that is what AC determines D here. As same functional dependencies are available in both the set. Earlier it is not available. After applying this inference rules, I got that functional dependency in G also. In the same way, here they given E determines AD. But here they given E determines AH. Then my aim is what it is. E determines A is available here also and E determines A is available here also. I need to check whether E determines D is there or not. Okay. So E determines D is not available. Once again, what is the procedure I have to do now? Once again, I have to infer that rule here. For inferring, which inference rules we used here? That is the transitive rule. E determines A is there and A determines D is there. After applying the transitive rule, I got E determines D here. Yes, this E determines D and this E determines D. Same functional dependencies are now available in F and G. Next is E determines H. Yes, E determines H is there and E determines H is here also. So now after finding closure of and F and G, I get to know that both are equivalent. Same set of functional dependencies are available in closure of F and also available in closure of G. So that's why these two are equivalent. Hence F and G are equivalent. In this way, we have to check whether these two are equivalent when after finding the closure of both the functional dependencies set here. Okay. So this is about your equivalence of sets of functional dependency.